Guys, Mr. Mac here. In this video, we're going to do a couple more example problems from 5.1 quadratic functions. We're going to take a look at some applications for the next two examples here. In this example 5, we're finding the maximum value of a quadratic function. Right, so maximum value means that we have some sort of parabola opening down, and we're trying to find that basically what is that vertex, that y position, to find the x and y, to find whatever that maximum is. In this case, the maximum is going to be area depending on the length of fencing. So we have a backyard farmer who wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of wiring fence to enclose 3 sides and choose a section of her backyard fence as the 4th side. Okay, so we have some sort of backyard fence here. That's that. And so that's the, that's our fence. And we've got 3 sides that get enclosed on that fence. Okay, so off of the fencing, we're going to have some sort of enclosed space here. So here's our enclosed area right here. So we have 3 sides, and then the fence is the 4th. Okay, write a formula for the area enclosed by the fence if the sides of the fencing to the existing fence, find a formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length. Okay, so we're saying that this is the length, perpendicular, and then I guess we can call this the width, because area is length times width. So let's write that. So area of a rectangle is length times the width. But we know that she's purchased 80 feet of length here, or total length, right? So this means that the length of the 3 sides here is going to be 80 feet. So the perimeter, well, it's not really perimeter. It's not the whole perimeter of the, let's say the wire fence, I'll just say wire, okay, wire, the length of the wire is going to be 2 L's, 2 L's, and 1 W, right? So the entire length of the wire is 2 of these L's and 1 W. And we know the wire's length is 80. It's 80 feet. Okay, so we need an area formula. So area, has 3 variables, A, L, and W. So I can't solve with these 3 unknowns, so I need to have something else. So what if we say, what if we subtract 2L here to both sides? So I get this equation in terms of W. So now my W equals 80 minus 2L. All right, the width would be 80 with these 2 lengths subtracted, right? Hope that makes sense. So why don't we replace W here with this expression 80 minus 2L? So I get area equals L times, parentheses, 80 minus 2L. Okay, find a formula for the area enclosed by the fence. Boom. And it's in terms of L right there. Okay. What dimension should she make her garden to maximize the enclosed area? So we really need to find the vertex here. The vertex is going to give us the max or the min. In this case, it's going to be the max. So I have this equation here, why don't we, a couple ways we can do this. Why don't we go ahead and put this in standard form? Okay, so let's write this in standard form, which means ax squared. So what is standard form? Again, here's our standard form of the equation. Ax squared plus bx plus c. F of x in this case is a, and our variable in this case is L. Okay, so let's multiply. All right, getting there. Let's distribute this L. So I get 80 L minus 2L squared. Okay, let's write the leading coefficient first, as we would do in standard form. Okay, there we go. We see that our A value is negative, so this is going to open down, which should make sense because we need a maximum value. And we need to find our vertex. So our vertex is hk, right? Our x and y values we call h and k. And the way we can find h is by saying negative b over 2a finds the x-coordinate of our vertex. So negative b is 80. Notice there's no c here, so my c value would be 0. Let's just write it. So a is negative 2, b is going to be 80, and then c would be 0. Okay? So I've got negative 80 divided by 2 times negative 2. Negative 80 divided by negative 4 is 20. Okay, so my h value is 20 right here. So I know my x. How do I get my y? Well, k is going to be, so this time we're going to put in our h value in for L here. So it's going to be negative 2 times 20 squared plus 80 times 20. Okay, so just make sure I put that in right. Negative 2 times 20 squared plus 80 times 20. Okay, we're going to do exponent first. Negative 2 times 400. 20 times 20 is 400. Okay, 8 times 2 is 16, and then 2 zeros. So my k value is 800, and that's going to be my vertex here. So my vertex is 20, 800. All right, so 20, 800, that's right there. And let's see here. Really found the answer to the question, but I want to take it the next step here. What if we wanted to find our x and y intercepts? That means we would put 0 in for a, so I would have, how about we take this equation right here and we just say L times 80 minus 2L, and we just set this to 0. So that means that I set L equal to 0, and then I would say 80 minus 2L equals 0. Let's zoom in. 40. So I get 0 and 40. So 40 is here, and 0 is here. So here we go. Here's our graph. It's going to look like that. Our axis of symmetry would be right here, through here. And this is our absolute max right here. So what absolute, I should say ABS max. So at a length of 20, we get a maximum area of 80. Okay? So if this length right here is 20, this makes this 20. 20 plus 20 is 40. I have 80 feet total. That's going to make this width right here 40 feet, right? 20 plus 20 plus 40 is 80. And 40 times 20 would be 800 feet squared. That we got here. Notice if the length were 0, that would mean that the width here is 80, and 0 times 80 is 0. I would have no area. If the length here were 40, this side would be 40, and this side would be 40, which means I wouldn't have any left over for the width, and it would be 0. So look, that's why we have these intercepts here where A is 0. This is no area here. Okay, there's not even a rectangle. Okay, we've answered the question. So what are dimensions she needs to make to maximize her enclosed garden? The garden, let's say the dimensions should be length equaling 20 feet and width equaling 40 feet for a max area of 800 feet squared. Okay. I hope that makes sense. A good maximization problem right there. Example 6, applying vertex and intercepts of a parabola. A ball is thrown upward from the top of a 40-foot high building. Okay. All right, so we're throwing a ball up 40 feet. Okay. Ball is thrown up. It's going to come back down, just barely miss the building, fall, and hit the ground. All right, so 80 feet per second is the speed it's being thrown vertically. And the height of the ball, h sub t, is modeled by this equation. So in time of t, as t elapses, our ball will be at different heights above the ground. So, or maybe at 1 second we're here, and then 2 seconds, 3, and then it's, it's falling, and then it hits the ground. Boom. All right? So this equation will tell us, depending on the t, t's the input, it'll tell us what the height is. And at some point, it's going to hit the ground. Okay, so when does the ball reach max height? What is the maximum height of the ball, and when does the ball hit the ground? So max height is going to be the vertex of some sort of parabola, right? This is a quadratic. Okay, we have a power of 2 here. You see it's negative. So parabola is going to, the height's going to start at 40, isn't it? Right? Because that's the height we are above the ground. It's going to go up and then come down, and wherever it hits the ground, right, that's going to be where the parabola hits the x-axis, which is time. All right, so we have to figure out where all that is, of course. So let's see if we can figure out what the vertex is. Vertex is where we know our max or min is going to be. So h, we know how to find the x component by using negative b over 2a. Okay, negative, so our b value is 80. 2a is negative 16. Okay, we're negative divided by negative. This is going to give us a positive number. And let's see. 80 divided by 32 is 22.5. All right, so that's going to be seconds. All right, so in 2.5 seconds, the ball is going to be at the highest point. So somewhere, I could even put my axis of symmetry here. Somewhere on this axis of symmetry is going to be my vertex. But I don't know the y yet until I plug it in. So my k value is going to be h of 2.5. Right? Because 2.5 is the h value that it's going to be the max. So that's going to be negative 16 times 2.5 squared plus 80 times 2.5 plus 40. There we go. All right, so I'm grabbing my calculator for this. My battery is low. Okay, so we got to do the exponent first. Actually, I'm just going to type the whole thing in. So I'm going to say negative 16 parentheses 2.5 parentheses squared plus 80 times 2.5 plus 40. And I got an error. Okay. I end up getting 140. 140. This is going to be in feet, isn't it? 140 feet. Okay, so I got my vertex. My vertex is going to be 2.5, comma, 140. .5, 140 right here. Okay, so this is our max. So part A, the ball, so it's asking us when. So the ball reaches the max height in t equals 2.5 seconds. And then B, the max height is 140. Okay. So I hope you see here that we're starting at 40 above the ground, right? At 0 seconds, okay, before we even throw the ball, we're already 40 feet above. And you could see here, if we were finding the the y-intercept, we would plug in 0 for t here. And I'll just do this really quickly. I hope you see that all of this cancels here, except for the 40 at the end, right? Plus 40. So all of this cancels, and my h of 0 is 40. So that means at 0 seconds, I'm at 40. So this is the y-intercept right there. All right, well, that means I'm going to have that mirrored on the other side, right? So at 5 seconds, I'm going to be 40 feet above the ground, okay? So it's going to be after 5 that it lands. I mean, somewhere between 5 and 6, my guess. Looks like it's going to come crashing. Boy, did I miss that. You know, looks like somewhere like that, right? How do we find exactly where it hits the ground? Well, that's the x-intercept, and what we do is we set our equation in standard form equal to 0. Just like that. Thing about this, though, guys, is this is not factorable, or it's not easily factorable, maybe not factorable at all. This, in case it's not going to be factorable. So I'm just going to put this in the quadratic formula, which you guys have in your notes if you need to check it. Negative 80 plus or minus square root of 80 squared minus 4 times negative 16 times 40 all over 2 times negative 16. So that's going to give us negative 80. Now, if we put this whole thing right here in our calculator, we end up getting plus or minus 94.7 is what I get, all over negative 32. So if I get negative 80 minus 94.7 divided by negative 32, that gives me negative 0.46. Okay, and now if I do negative 80 minus 94.7 divided by a negative number, that gives me 5.45, something like that. Okay, so that means I have an x-intercept at negative, so over here would be negative 1, would be like here, and then the other one is at 5.45, about 5.5. And so when we put in our sketch here, something like that, right? And look, we're going back in time here for that negative. That doesn't really make sense. But this is negative, that's 5.45. You know, at 0, we're starting at 40. So you have to go into negative time for that ball's path to go hit on the ground on that side. So that doesn't make sense to go negative time, so our actual answer is 5.45. So it will take 5.45 seconds to hit the ground after we throw it. The ball hits the ground in 5.45 seconds. Okay, a little bit of physics there for you guys. All right. I'm going to stop this video and I'll make another one for example 7, 8, 9. Hope that makes sense.